Hello and welcome to our Engineering 6 final project presentation. Our group is called the SpaceMonkeys and we'll be doing our project on Steganography. My name is Brian Thomas and I was the lead for flattening and expanding the images as well as the reach aspects of this project.
My name is Dzmitrij. I was the primary lead for the encryption and encryption functions of the project.
And my name is Nathan Love, and I was in charge of the GUI, but all of us equally contributed to the entire program. So I'm going to be explaining the GUI and how an overview of how the code works and just the flow of data and everything like that. So our GUI is set up with the Home tab. There are 3 different tabs. The Home tab, 4 different tabs. The Home tab, Encrypt, Decrypt, and the Info tab. In the Encrypt tab, we have an Upload Image button with an axis, and the user will click on the Upload Image button, and if it is not 400 by 400, it will respond with an error. Otherwise, it will display the image on the axis. Then the user will choose the number of images that they would like to encrypt, and then the number of image axes as well as the upload buttons will display on the GUI. Then the user will choose the method that they would like to use, which is talked about later on, and then that value, that method, will be set in the code. And then they will click the encrypt button, and first it makes a sound, which Brian will talk about in the reach section, and then it pulls all of the images that were uploaded to the axes, and the switch statement then is what is used to decide how it is going to encrypt the image based on the method that was chosen. And then it opens the encrypted image in a new figure to save that image because MATLAB does not support saving. Our next tab we have is the decrypt, and what the user will do is upload an encrypted image, and then it will display that image on the axes. Then the user will choose the number of images that they would like to decrypt from that encrypted image, and then it will again display those number of boxes that will be filled by the decoded images, the images that were pulled off of the encrypted image. Then they will choose the method that they would like to decrypt with, and then they'll click the decrypt button, and it will pull the uploaded image that the user uploaded, and then it runs it through our decryption function, which we'll talk about later. Then it shoves each image that was pulled from that into the axes that were displayed, and then it pulls up a subplot of all of those images that the user can then save. Finally, we have our Info tab, and in the spirit of being the SpaceMonkeys, it gives a little introduction as to why we might want to use our decrypt functions and just this GUI in general to overthrow the human oppressors. And so yeah, that is our GUI. And next we got Brian coming in to talk about our Home tab, which has a GIF associated with it as well. Brian, take it away.
Alright, so the 2 reach components that we added to the GUI was one, we wanted an animation. So unfortunately GIFs are not supported with the app designer. So what we ended up doing is making a plot and running a loop that redraws circles that would make a spiraling effect you see when you run the application. And the other reach component that we added was a soundbite and a monkey howling whenever you encrypt or decrypt.
And I'll be talking about the encryption portion of our application, and I'll walk you through the flowchart for encrypting a user image. So the first step after we get the user image is to split it into 3 different layers, the RGB layers, thus allowing us to encrypt each layer individually. After we separate the image into layers, we create a bitmap based on how many secret images the user wants to encrypt. The bitmap was my primary focus, and I'll be talking about the challenges associated with it later. So after we created the bitmap, depending on the user input, we then have to flatten the secret images. The flattening function was created by Brian, who will be talking about it later. After the flatten function, the user has to decide what encryption method he or she wants to use. So in here we can see that after the flatten function, the flowchart is separated into the standard use and the layer encryption use. The standard use is encrypting the layer sequentially. So let's say the user has 3 images that wants to be encrypted. We're gonna hide every single image into individual layers. So 1 secret image per 1 layer. When we're encrypting the image, we have to make sure that the pixel value of the original image that we changed is within the range, so the value is not offsetted too much, so you won't be able to tell the difference. The layer encryption is different from standard encryption because the layer is actually shoving the maximum number of pictures into 1 layer. So let's say the user wants to encrypt 4 images. We're gonna shove all 4 images into 1 layer. We're not gonna split them into 3 different layers. So after we encrypt all the layers, the last thing is left is recombining the encrypted layers into original image, thus creating the encrypted image that contains all the secret images provided by the user.
In order to encrypt 10 different hidden images into our original image, we need to create a flatten function that will convert the image from grayscale to black and white. In addition, we will also need to create an expansion function that will then convert the image from black and white and back into RGB values. The best way to explain and show this is through looking at the code. Our flattening function is assigned either a 1 meaning black or 0 meaning white value depending on the 256-bit value for each pixel. As you can see, we have a nested loop that runs through each pixel and assigns the pixel a 0 or 1 value depending on whether the image grayscale value exceeds our set threshold.
One of the challenges of this project was to create an encryption method that would create an encrypted image that's not too different from the original image. Thus meaning that if you would compare the original image to the encrypted image, you would not be able to tell the difference by simply looking at it. This was accomplished by creating a bitmap value. So let's say the original pixel that the user wants to hide is 15, and the user wants to hide values 0000, which are part of the 4 hidden secret images. This is simply accomplished by looking at the bitmap. So the hidden value is 000, we look at the number of secret per layer 000, and the original value is 15, meaning that the user pixel is 15, so we can choose between 2 values, 0 and 16. Obviously we want to choose number 16 because it's closer to the original value, meaning that it will be much harder to tell the color difference. Therefore, the encrypted pixel will actually be like 16. This method is applied to every single pixel in the original image based on the hidden pixel that the user wants to encrypt.
So we are going to be going through the decryption function. What this function does is first it reads the image that is passed to that function. And for each image, for each layer of that image, the RGB image, it goes, for each pixel, it goes to the bitmap. Say for example that we are trying to decrypt 4 images and 1 pixel is valued at 17. Goes over to this bitmap and it'll take 17 and then it'll replace that with 0001. It ends up being a 3-dimensional matrix with 4 layers. The first layer, being that 0, is corresponding to our hidden 1 image, then hidden 2, then hidden 3, then hidden 4. Then what it does is it selects the layer to display and then sends that layer to the axes that you desire. And then it also pulls up a subplot for the user to save. And that's how the decryption function works.
Okay, so now we're taking a look at the application itself. As you can see, it's got a pretty attractive display. We have the GIF, which is really just a loop running in the background, just to give it a little extra flair. And so the first step you would do is you click on encryption, which which prompts that monkey sound. And you want to upload a plain image. And now you want to select the number of images you wish to hide within that photo. So we're going to choose 2 for this first example. Now we're going to choose what method to use. Either one is fine. And you click encrypt. Another monkey sound. And so now the original images is encrypted with the hidden images. And so we will save this image as a new file. Okay, we'll go back to the Home tab. So now that we're back on the Home tab, we'll click Decrypt. We're now going to upload the image that we just saved photos in. Now we choose the number of hidden images that we embedded in it. Choose the method we wish to decrypt, which is the same method you use to embed. When we click Decrypt, we will get our hidden images.